Hello, my name is Connie Louisa Holali Echo, and I am representing on our end of semester final project for DCIT 204, Finding the Shortest Route on Campus, Fast Route, UG Navigate. We are a team of 7 members, and each team member has been dedicated. I wrote the algorithm from my group, and so the algorithm showing on the screen will be explained in the easiest form for us all to understand. Thank you. To find the best route on campus, we use the Gestrat algorithm, and Gestrat algorithm is a method that is used to find the shortest path between 2 points. Imagine each building on UG campus to be a dot, which is a vectors, and then the lines between them as edges, called the distances or with distances. So to start, we begin at a starting point and set its distance to 0. All other locations start with an infinite distance. We look at the neighboring locations and calculate the distance through each point. If we find a shorter path to a location, we update its distance. We continue this process until we have found the shortest path to all locations. We use a table to store the location and the distance between them. This helps us to keep track of which routes are the shortest. Then finally, we use the Vogue approximation, which help us to refine our route choices considering both distance and time. This one shows our flowchart, which we drew for our algorithm. Thank you, and my team members will take it from here.
The max penalty method finds the maximum penalty in the row or column. It iterates through each row or column and calculates the penalty using the different method over here. It keeps track of the maximum penalty and returns the position of the maximum penalty, the minimum cost, and the associated row or column over here. Now we'll move on to the next algorithm used in this project, that is the A star algorithm. This algorithm is an efficient algorithm that is used in pathfinding and graph traversal. Over here, we just import the same some of the classes we imported in the previous algorithm implementation, and all these classes are the edge, graph, and node. We also import the java.util package, which contains classes like priority queue, array list, etc. The main class of this algorithm is A star over here. Now, all the variables found in this algorithm or that we use in this particular implementation is the find fastest path, which contains parameters of graph, node source, and node destination. In terms of initialization process, we have the use of open set. Open set hash came from G score and F core. These initializations are various priority queues that perform specific functions like tracking nodes that need to be evaluated, creating auxiliary structures to track the contents of another priority queue. For example, OpenSet hash tracking the contents of OpenSet came from other priority queues. Now move on to the heuristic function. This function estimates the cost from the current node to its destination, as you can see over here. Up next, we would add the source node to the OpenSet over here to mark the start of the algorithm. Now to the main loop of the algorithm. The main loop of the algorithm continues until there are no more nodes to evaluate in OpenSet over here. Coming down, we find the main set variable, and this particular variable refers to the node with the lowest F score and is selected from the OpenSet using the get key method. current over here refers to the node with the lowest F score. The current node with the lowest F score. If it is equal to the destination, the loop then terminates or stops, and the shortest path is reconstructed using the came from map. After that, we can also explore the neighboring nodes connected to the current node. This can help us obtain the potential cost to reach a neighbor, and that is calculated by adding the time travel to the G score of the current node. So now this code over here updates the various scores. That is, can update the G score, can update the came from, can update the F score, and add an open set to the algorithm. After that, once the destination is reached, this method over here is used to backtrack to the came from map to construct the shortest path from the source to the destination. Path can also be reversed. Next, we have the heuristic function over here. This estimates the cost to reach the destination from the given node.
This Java class defines an edge in a graph structure which connects two node objects and has attributes like time, distance, and landmarks. The class implements the comparable and clonable interfaces, allowing for comparisons between edges based on distance and clone of edges instances. Here is a breakdown of the class. The attributes are node source, the starting node of the edge, node destination, the ending node of the edge, int time, the time taken to traverse the edge, which is optional. It could be -1 if not set. The double distance, which is the distance between the source and destination nodes. The string landmarks, which is additional descriptive information about the edge. Constructors. The first constructor initializes edge with source, destination, and distance. The time is set to -1, and the landmarks are set to an empty string. The second constructor initializes edge with source, destination, time, and distance. Landmarks are set to an empty string. The third constructor initializes edge with source, destination, time, distance, and landmarks. The methods used are getSource, which returns the source node, setSource, which sets the source node, getDestination, which returns the destination node, setDestination, which sets the destination node, getTime, which returns the time associated with the edge, getLandmarks, which returns the landmarks associated with the edge, getDistance, which returns the distance of the edge. ToString provides a representation of the edge in the format source to destination distance. Compared to, it compares two edges based on their distance. The clone creates a copy of the current edge object. The comparable interface, the compare_to method, is used to compare edges based on their distance, which can be useful in sorting or priority queues. The clonable interface, the clone method allows creating an exact copy of the edge, useful when you need a duplicate instance. Thank you.
This code consists of two Java classes, Node and UGMAP. Each class serves a distinct purpose within the context of Java application. The Node class is designed to represent a node in a graph structure. Thus, the part of a mapping or routing algorithm. A private string name is a field which holds the name of the node, which represents a location, point of interest, or any other entity in the graph. Public node into bracket string name is a constructor that initializes the node object with a given name. The name provided will be stored in the name field. Public string getName is a method that returns the name of the node. At override public boolean equals into bracket object obj method overrides the default equals method in the object to provide a way to compare the two node objects. It checks if the provided obj is an instance of node. If it is, it will compare the two name field of the nodes. If the name matches, the nodes are considered equal. At override public string to string method overrides the default to string method in object to return the name of the node. Public class UG extends Canva, making it a graphical component that can be drawn on. The primary function of this class is to render an image on the Canva, which could be a map or any other visual representation related to the application. Public class UGMap extends Canva contains the Canva class in the abstract window toolkit, which provides a blank area on which custom graphics can be drawn. By extending Canva, UGMap becomes a drawable surface in the application graphical user interface. At override public void paint into bracket graphicsGen method is responsible for rendering content on the Canva. And g.setColor into bracket color.chan set the drawing color to the color chan. This could be used for drawing shapes or text, but as used here, it is setting the color before loading the image. Toolkit T is equal to toolkit.getDefault toolkit into bracket. It's a default toolkit, which is a platform-specific implementation that allows access to system resources like the images. Image I is equal to t.getImage into bracket the path name of the image loads the image from the specific file path. This image is expected to be located on the user's desktop. Gene.drawImage into bracket I, 10, 10, draws the loaded image on the Canva coordinates 10, 10, and this keyword refers to the UG map object.
My name is YVcz1c7u, and I'll take you through the Dijkstra's algorithm. The Dijkstra's algorithm is an algorithm which is used to find the shortest path between two nodes in a graph. Now, let me take you through the code. First of all, let's look at the import statement. The import statement imports necessary classes, which is the node, edge, and the graph, and these represent the basic elements of the graph. When we come to the variables, the unvested variable keeps track of all the nodes in the graph that haven't been vested yet. The distance map variable stores the minimum distance from the source node to every other node. Then, the previous node variable tracks the previous node for each node, which helps us to find the shortest path. The find shortest path method finds the shortest path between a source node and a destination node in the graph. So first of all, It will initialize every node's distance to infinity. Then it will set their previous node to now. Then repeats the algorithm then repeatedly picks the unvisited node with the smallest known distance. Then it will mark it as visited. Then it will check its neighbors to see if a shorter path to them is found through this node. So after it has done this process will continue until all the nodes are visited and we will find the shortest path to the destination node. Now let's get to the get distance method. So the get distance method returns the distance from the source node to a specific destination node. It will convert the distance from meters to kilometers. Then it will return it as a string. So after finding the shortest path, the get shortest path method will recreate the path from the source node to the destination node by backtracking through the previous node map. Then this find vertex with min dist method will find the unvisited node with the smallest distance from the source node, and this node will be the next one to be visited and explored. So to summarize it all, the Jigsaw algorithm is used to find the shortest path between two nodes in a graph. Using this code, this algorithm makes sure that the shortest and most effective path is found by carefully examining the graph and recording the minimum distances in previous nodes. Thank you.
Welcome, Samuel. Welcome to Data Structures and Algorithm 2023-2024, Group 11. And my task was to implement find the shortest distance from the gym center to the main gate. And this is how I went about. Class node, I created a class node edge graph, and a method to calculate the path distance, the path before. And then I implemented a main Java class which calculates the nodes and the edges. I implemented code end. This is how I put path. The first one was from the Nigerian diaspora, night market, Omo, Rota or Lebanon or Sabah or Papo, Sibas, and the distance was 4,988.0 kilometers. Starting with how I implemented the node class. The purpose of the node class was to represent a vectors in the graph, and the attribute name was just to give the node a name, and the public string get name was to retrieve the name given to the node, and then the class edge was to find the edges between two nodes, was to find the edges, and we have a starting point and the ending point, and then we have, and then the distance between the start to the end. And the graph class first started with a method, and the adjust placed method, and the adjust placed method was to the adjacent list where each node maps to a list of edges. That was what the adjust list method does. So we went to the find shortest And the method was to initialize distance to infinity. And then the starting point should be equal to zero. And then uses the priority queue to exploit the nodes with the smallest known distance and update the previous nodes. So that's how I went about finding the shortest. Um, the algorithm used was depth first set to exploit all the path and track the current path and its distance. If the end node is reached, record the path and distance in a sequence with if all the nodes run through the bone or suburb, then it reaches the main we just record on the path of not was to reduce some path size from the distances. And I implemented double 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 calculate path distance. So first initialize it to zero and I use the following to calculate the size starting from the starting point to the end point. And if the adjacent of a new norm, then it's added to the distance dot age. And then after that it breaks, then it returns the distance. The class now moving on to the class path, and this is how I wrote about the path info. So the main purpose of the path info was to stores information about a specific path, store information about a specific path. And some of the attributes I used was the path. And the path was, the path was a list of nodes representing the path. Yeah. The distance between the path. Yeah. And I implemented a string class which returns the string representation of the path if it's distance, making it easy to print and read. So I did this in order to make it easy to print and read the amount. And the end event append was to append distance to each distance and returns that using the string class. And the main class I implemented not so giving nodes during diaspora, night market, Sabaho, Gates Home, Law School, CS department, and I also added edges. So the edge is the distance between the two nodes, Gen, comma, diaspora, 500 kilometers. Just like the graph, diaspora, comma, as of comma, 400 was 400, and also 9 minus 2 was 914 kilometers. And comma was always 400, and so that's how I did the idea. And this is how I print out the node. This is how I so the steps as I initialize the graph, I created a new graph. Yeah, and I created a new graph. And then I define the nodes added edges. So here I find a node and added edges. And first I find print all the path. So I use this graph.find graph.find on the graph from the gene center to the remaining bits. And then after that I printed the shortest distance from the gym center to the main bits. And this is the conclusion of my book. This book efficiently handles the graph-based path farming using the algorithm for the shortest path, and I use the depth first search approach for finding all the paths. And the main class demonstrates how these functionalities solve the practical problems.